Hi everyone, myself J Vanitha. I am working as an assistant professor in the Department of Chemistry in Siddharth Institute of Science and Technology, Puttur. Today I will explaining about superconductors. In this lecture video, I will explain what is meant by superconductor, what are the materials that can exhibit the superconductivity nature, types of superconductors, properties of superconductors, applications of superconductors. Before discussing what superconductors, how the materials are classified. According to the materials can be classified according to the ability of to conduct electricity. The materials are classified into four types: conductors, insulators, semiconductors, and superconductors. Conductors means the substances or the materials which can easily allow the electric current is called the conductors. Example is aluminium, copper, etc. Insulators. The substances or the materials which does not allow the electric current is called insulators. Example is paper, wood, etc. Semiconductors. The materials are the substances which has the properties of both conductors and insulators is called the semiconductors. Example for this semiconductor is silicon, germanium, etc. Now superconductors. Superconductors means at zero resistance, the electricity can be conducts. A type of materials is called the superconducting materials. The material which can conduct electricity or transport electrons from one atom to another atom with zero resistance is called the superconducting materials. Or another way we can say that the materials which can conduct electricity at zero resistivity or infinite conductivity is called the superconducting materials. Best example for these superconducting materials is niobium and magnesium diboride is the best example for superconducting materials. And next one is superconductivity. What are the materials exhibits the superconductivity nature? For the best term or the important term used in this superconductivity is critical temperature. That means the temperature at which a material electrical resistivity drops to absolute zero is called the critical temperature. It can be denoted by Tc. Most of the known superconductors are alloys or compounds, but the superconductivity is not exhibited by any of the magnetic material like chromium, manganese, iron, cobalt, and nickel. In the graph, we can see that in x-axis we can take the temperature and y-axis we can take the electrical resistivity. If the temperature increases, the electrical resistivity and can be increases for the normal metal. But in case of superconductor material, the electrical resistivity suddenly drops to absolute zero. At that temperature, we can call it as a critical temperature. At that temperature only, the material can exhibit the superconductivity nature. And next one is types of superconductors. Superconductors are classified into two types: type 1 superconductors and type 2 superconductors. And next one is type 1 superconductors. Type 1 superconductors are also called as soft superconductors. Why type 1 superconductors are soft superconductors means when we apply external magnetic field, it loses their superconductivity easily. So the type of materials is called as a soft superconductors, and it also exhibits the Meissner effect. Meissner effect means the superconductivity will tend or does not allow the all magnetic field. That type of phenomenon is called Meissner effect. And the critical temperature value is very low. That means less than 10 Kelvin. Some of the metals and its critical temperature value for type 1 superconductors can be given below. Aluminium at 1.2 Kelvin, the electrical resistivity can suddenly drops to zero and it can behave as a superconducting material. Next one is cadmium at 0.6 Kelvin. Next one is tin at 0.3 3.72 Kelvin, it can behave as a superconducting material. For mercury, 4.2 Kelvin. For lead, 7.2 Kelvin. And next one is type 2 superconductors. Type 2 superconductors can also called as hot superconductors. Why type 2 superconductors can be called as a hot superconductors means when external magnetic field can apply to the superconducting material, it can it does not loses the superconductivity but gradually decreases. So it does not easily loses the superconducting nature. It does not exhibit Meissner effect. The critical temperature value is also very high, up to 130 Kelvin. Best example is niobium, germanium, niobium, silicon is the best example for type 2 superconductors. Some of the metals and its critical temperature value can be shown below for type 2 superconductors. For niobium aluminum at 18 Kelvin, it can suddenly, the electrical resistivity suddenly drops to 0 and it behaves as a superconducting material. For niobium tin, 18.1 Kelvin. For niobium germanium, 23.2 Kelvin. For magnesium diboride, 39 Kelvin. At the temperature, it can suddenly, the electrical resistivity drops to 0 and behaves as a superconducting material. And next one is properties of superconductors. Mainly, the superconductor properties as follow as it can behave as it is a zero electrical resistance. At that resistance, the temperature, zero electrical resistance only, it can conduct electricity and Meissner effect. And main important term is critical temperature. Applications of superconductors. Applications of superconductors in nowadays, superconductors can play a major role in various fields like medical, military, electric motors, etc. Mainly used in these superconductors are nowadays particle accelerators, generators, transportation. We can best example is maglev train, power transmission, electric motors, military, computing. In medical purposes, we can use MRI, magnetic resonance image. We can be used as superconductor materials and B field detectors. Semiconducting materials allow low power dissipation, high speed operation, and high sensitivity also. Firstly, it was discovered in mercury and similar behavior has found in 25 and other chemical elements and now in thousands of alloys and compounds can be discovered. Superconductors have main applications in transformers, generators, medical imaging, computing, computer components, etc. Thank you.